Welcome to another teardown video. This is going to be a little bit different from what I normally do. This unit is actually a unit that I designed 30 years ago. When I was in the last bit of my first education, I designed and built and manufactured by hand 14 units for battery charge and discharge and cycling and conditioning of nickel cadmium and nickel metal hydride cells. So this is made by hand by me 30 years ago. And I haven't seen this thing for 30 years. This unit is now back in my hands. And it is really, really funny to see it. Of course I can see that some years of use and abuse went into this thing. I tried to use this button and then it broke. It was kind of stuck. So this one is broke. But look at this one. There's almost no spring left. It's just and this one is super loose. So this is absolutely funny to see this. So how this works is it is completely made without microcontrollers. It's just counters and such, and voltage comparators and stopping the time. So the time is what is converted into capacity, and capacity is 100%. So it's always reading out 100%. And what you do is you pick your battery. Say if your battery is 1.2 amp hours, if you are discharging with 1.2 amp, it will take 1 hour, right? So this is the 1, 2, and 4, the multiplication for the time. So of course, half of the current. That means now the timer is just counting half the time. So if this takes 2 hours, then it is again 100% on the display, and so forth. And of course the charge current. And here you set the hours, and then you look in this table. What is the battery capacity? Okay, I want to charge for that many hours. Then the loss factor, or the extra charge current, is just added to the current, and then after 10 hours it stops. It is that simple, and it will automatically switch between charge and discharge and all those things to do a number of cycles. So when you stop this is simply done by selecting how many cells. So if you select 8 cells, it will stop the discharge when there's 8 volts on the pack. Really simple. So this is the discharge time. 1, 2, and 4 hours. And this is how many times it's doing the conditioning. So if it's doing conditioning 1, then it will discharge and charge. That's it. 2 to 9, and it will continue until you stop it, or it will stop at 9 cycles. So the extra digits here actually show the number of cycles. Those are added later as an upgrade. All right, maybe we should, I don't know how this works. Well, maybe we should try and plug it in and see how much smoke there is in this one. Then just love this switch. So this is conveniently located near the unit. I can't remember ever making a product with a switch like this. So yeah, so there's no switch here or anything. The power just go in, and that's it. A really nice heat sink for the power, and I can see a resistor and some power devices, maybe just some transistors and stuff. I can't even remember half of this. So now let's try and ooh, beep beep. And then what? No. Aha! So this is the conditioning. Ah, so that is yeah, that's right, the normal mode. So you can start, yeah, exactly. So you can start the charger and the discharger independently. Because if you're in normal mode, the charger is half of this. This is how you set the charging hours and the charging current. And you can use the separate connectors for the charger part. Or you can use the discharger at the same time in normal mode. This is really, really fancy made. So when you're in conditioning, that means they are connected together. So this one will be conditioning, charge and discharge and whatnot. And in this mode, this is not used. This is disconnected by a relay. You can hear the relay. Yeah, so that is how it works. But then you use this start button that is broken. Maybe we should open it and see what's inside, right? So now I took out all 8 screws. Also what you should maybe see here, since everything here was made by hand. So even this label here is actually a light sensitive film on top of some sticky aluminium. So you give this light in UV and then develop this so the black coating will go away, and then you get this really nice and shiny label, and then you spray varnish this label and you can stick it onto something. And this is also how the front panel was made. So this is a really easy way to make quite professional looking products. Well, of course, all the holes and everything here was manually drilled, as far as I remember. So maybe we should see, because as far as I remember, everything was hand made. Oh yes, indeed. Don't you just love it? Oh. This is really heavy. One layer PCB, and I remember this is done with something called letraset or some sticky tape on a transparent film, and you just rub the different symbols and everything onto the transparent film, and then you can develop the PCB and etch away the copper and so on. Oh, look at that. That is really cute. Some capacitors across the diodes. Oh yeah, I remember this way of rectifying. This is really, really cute. So this is a double winding, right? 2 times 15 volts. So we have 15 here and 15 here, right? So the 2 at the end. Oh, yes, yes. Look at that. This is exactly what it is. So the 2 at the end go to the bridge. And this is what goes to one of the capacitors. But then look, there's another diode. only one diode from the center point going to the other capacitor. Maybe it's that one. So that way you have only one diode to create half of the voltage. And this is also done by 100 Hertz rectifying, but only using one diode. See, that is quite smart, because this one is using one of the ground diodes alternating, right? So this is actually also using both sides to create 100 Hertz half voltage DC. So that is the trick with this power supply. And I think initially there was supposed to be some regulators here or something. It just didn't work out that way. So this gotta be a prototype. I was hoping to see some handwritten dates or information in here, but I don't see any of that. Of course, this is one of the very early prototypes using proto board and hand soldering all the wires. Can you imagine the time that it will take to do this? Amazing. So that will be all the display decoding. And here's some counting and decoding, and a lot of counting and stuff going on here. And the current generator is done by an op amp, sense resistor for current, and fine tuning of the current. Ooh, we want this to be accurate, don't we? Shall we look at the PCB and go for the big shock? Ah, yes indeed. Yes, I was right. Look at that. It was 92, so it is 30 years ago. And this is number 1. It says number 1 on the PCB layout, but it says serial number 3 on the PCB. Somebody's been debugging around with the pins on this counter. Whoa, look at all the wires and look at all the SMG parts, and a little missing. Don't you just love it when you see stuff like this 30 years later? Wow, this is just like going through a time capsule. What have we here? All those funny capacitors and stuff. What is this doing? Thingy for the thin shitty wire. So this is going for the power transistors, charge and discharge. Remember, this can do charge and discharge at the same time. So, yep. And of course, look at the resistors. 1% resistors, yeah. No expense saved. That is how you do it. Ha ha. 30 years ago. I maybe was lucky with that, I guess. Well. So, that was actually what I wanted to show. How I did it manually 30 years ago when I was just a snotty kid. Oh my god. I hope the other 14 units looked a little bit more professional and not all this wired shit, man. If somebody ever finds one of these in somebody's attic or whatever, please send me some pictures. I would love to see how the others look, because I completely forgot about it. I think I'm gonna put this back together and put it in my museum of old funny stuff that I just don't have the heart to throw out. Thank you very much for watching. I said thank you, go away. This is the jumper setting. Now I remember. Yeah, this 2 to 9. That means it will do the number programmed by the switches in here. This is how you program stuff without microcontrollers for programming. Oh, don't you just love it?